All right, everybody, welcome back. Let's look at our next set of problems. This is homework number 8, if I remember correctly. Okay, this one should not be as long as the last video, so we're going to kind of jump into it real quick. According to this statement here, I want to know is true or false. Looking at this equation, it has infinite solutions. Well, remember, if I have infinite solutions, what I need to have is the same constant and the same coefficient. Okay, so if I do those will cancel out, and I should end up with the equation equaling 0 equals 0. So let's kind of look at it real quick. Well, first off, I see two sets of parentheses, but I'm going to work one side at a time. Well, inside this parentheses, I have a variable that doesn't have a number, so I'm going to give it a 1 for the sake of giving it to it. Okay, so here I'm going to rainbow here. We're going to distribute this 11 to the parentheses. Well, 11 times 1x is 11x. 11 times negative 3. Remember, a lot of this, y'all are still confused a little bit with this one. Remember, this means, I know it says minus 3, but it actually, remember, this is a negative 3. So a positive 11 times a negative 3 is a negative 33. Well, if I go over here, again, I have that negative sign. So it's just like the last one we worked on the previous video. Remember, what this actually means is just take the opposite of what's on the inside. But again, what you're actually doing is distributing a negative 1. Okay? So if I draw my to show the distribution, negative 1 times a positive 3 is negative 3. Okay, negative 1 times negative 11x would give me a positive 11x, right? Okay, so if I'm looking here, what I see is, remember, I'm looking for infinite solution, which means I have the same coefficient and the same constant. Well, if I look, let's go with box, circle. Let's kind of give us a visual. We have a circle here and we have a box here, right? Well, if I'm looking up here, well, if I look at my coefficients, they are the same, 11x and 11x. Both of them are positive, so actually they would cancel out. Okay, but if I look inside the two circles here, which are my numbers, my constants, I have negative 33 equals negative 3. Well, that's a false statement. They are different numbers. This is a false statement. So this is false. It does not have infinite solutions. It has no solutions. All right? So just keep in mind, remember, coefficients have to be the same. Constants have to be the same for infinite. All right? No solutions are same constant, same coefficients, different constants. Okay? All right. Two perfect squares would be between, I'm sorry, 89. The square root of 89 would be between what? Two perfect squares. So if I'm making my perfect squares, if I was to make my number line, if I'm looking for the numbers. Now again, this time, the last time we were looking for the whole numbers. Here, all I'm looking for is a number that I can put between, well, the perfect squares. The first perfect square below 89 would be 81. The first perfect square would be above it would be 100. So 89 would be between 81 and 100. Okay? All right? What about the next one? Okay, written in correct scientific notation. Okay, for a number to be written in correct scientific notation, the coefficient must be greater than or equal to, well, remember we talked about, oh, why is this thing jumping? I do apologize. Okay, it has to be greater than or equal to 1, but less than 10. So it's got to be between 1 and 9.999 whatever. Okay, now the base is critical here. It must be 10 at all times. So if it's not 10, it's not going to be the same. But remember, I gave you a shortcut with this one to make sure you never miss this one. Whenever you have your decimal, always look how many numbers are to the left of the decimal. There can only be one number to the left of the decimal and for it to be in correct scientific notation. So one non-zero number, okay? All right? Well, if you look here, so circle the numbers written in correct scientific notation. Well, first off, right off the bat, I see right now this is really, really, really big. It's much bigger than 10, but if you look, there are 1, 2, 3 numbers in front of the decimal. All right? That's a no-no. All right? Here, 2.5, there's one number in the front. Base is 10. That one's correct. What about this guy? There's no decimal. Well, yes, it's understood to be right here. But again, if you go back right here, greater than or equal to 1. Well, 1 is equal to 1. Base is 10, so there's a good one. Now, a lot of you are still kind of confused just a little bit about this one. Remember, just because this is a negative number, you're saying, well, that's smaller than 1. Yes, but remember, we're looking at the actual number, not the sign, when we're trying to determine if it's a correct scientific notation. There's only one number to the left, but look right here. The base is 11. Okay, that one's not in correct scientific notation. Even though the coefficient was right, the base was wrong. Here again, two numbers. There's two numbers here, plus this is way bigger than 10, so that's a no-no. All right, 1.01 times 10 to the 0, or 10 to the no power, right? Well, it doesn't matter really right now what the exponent is, okay? But if I look, this exponent, this coefficient only has one number to the left. 1.01 is greater than 1. The base is 10. That one is incorrect scientific notation. All right, look at this one, 0.25 times 10 to the first power. Well, my base is 10, but look at my coefficient. The number to the left is a 0. We can't have that, plus 0.25 is less than, not greater than or equal to 1, so this one is not correct. Okay, now this is the same coefficient, but now look at your exponent and your base. We reversed them, so we have correct coefficient, correct base. There's a good one. All right. All right, let's put these in order, least to greatest. Well, first off, I see some things I want to fix up here. Let's look right here. First off, I see 4 squared is 16. 3 squared is 27, excuse me. Remember, that's 3 times 3 times 3, right? Well, if I'm looking now, then you can use your calculator. If I take the square root of 22, and again, you're going to have your calculator, so take your calculator. Let's go ahead and change everything to the same terms. So we say 22 square root is just rounded up to 4.7. All right, so 4.7 is the square root of 22. 7.9, and then the square root of 12 we know is between the square root of 9 and the square root of 16, but we're going to go ahead, since we're converting everything, let's go ahead and convert the square root of 12. Okay, so now we can look at it as 3.46, which rounds to approximately 3.5, right? All right, so if we put these in order, least to greatest, now everything is the same, similar, even though these are decimals. These don't have decimal, but they do have 0 behind them, right? So we can put them in order least to greatest. Well, if I start with the least, I'm not going to put this 3.5. I'm going to put the square root of 12, which crosses this one out. The next number up would be the square root of 22. So then we're down to 7.9, 16, and 27. Well, 7.9 would be next. All right. Then we have 4 squared and 3 to the third. Well, here's a giveaway here. The exponent's bigger, right? So let's make sure really quick. So 4 squared and 3 to the third power. So there they are in the orders from largest to smallest, and I just sat here and did it completely backwards, didn't I? Okay, so what we need to do is, and I do apologize, and I did what you guys do sometimes, I get in a big hurry just like you do. So let's fix this from largest to smallest, which means we need to reverse the order, and I am so sorry. So the bigger number is 3 to the third, and then we have 4 squared, and then we have 7.9, and then we have the square root of 22, and then we have the square root of 12. So again, please slow down, because I guarantee you on the test tomorrow and when we get to the milestones, you're going to have them in both orders, least to greatest and greatest to least to greatest and largest to smallest. So please watch it, because this is the correct answer, and I do apologize. I'm sorry. All right, estimating square roots to the nearest tenth. Well, with this one, again, you're going to have your calculator, but I want to show you how to remember how we do it without a calculator. Okay, so we have the square root of 46 is between the square root of 36 and the square root of 49, right? Which means it's between 6 and 7. All right, so we say it's going to be 6 point something. We just got to figure out 6 point what. All right, so let's create our fraction right quick. So 46 minus 36 is 10. 49 minus 36 is 13. All right, so we got to turn this into a decimal, and I'm going to do it the long way. I know some of you don't like long division, but we're going to do it the long way. Remember, denominators stay outside, numerators go inside. Well, 13 will not go into 10, so we bring that up. Now 13 goes into 100. How many times would it go in without going over? That's going to be 7. So we're going to subtract the 9. We're going to bring down one more, because it says round to the nearest tenth, which means I need one more. Well, how many times will 13 go into 90 without going over? Well, you know it's not 7, so it's got to be 6, right? So that's going to be 78. And again, that's 12. So now I have 0.76. Well, remember, the 6 tells me to round up to the 7. So the 7 is going to become 0.8, right? So my answer here is 6 and 10/13, excuse me, 6.8. So the best estimate for the square root of 46, remember since it's an estimate, is approximately equal to 6.8. All right, so there's your answer for that one. All right, the last one, I'm sorry, 16, excuse me. All right, we're multiplying. We want to simplify this. Well, if I look up here, this is the same basis. And guys, you guys have knocked this part out of the park. When I give you this, you can tell me really quick. But what I want to make sure we do here, please remember, this is a base. This is not a coefficient. We're not going to be able to multiply these two together. This is a base. We're going to keep the base. And since we're multiplying, we've got to add our exponents. -7 plus 5. Well, -7 plus 5 is -2. All right? So -7 plus 5 is -2. Now, we're not quite finished because I have a negative exponent. So we're going to change this. Remember, put it 1 over it, change the sign. And then we're still not finished because I can answer this part because I know 3 to the second power is 1 over 9. Okay? There's your final answer to that one. All right? 17. We're almost done. Hang loose, guys. Solve the following equation for W. Well, I want to know what the value of W is. Okay? I'm not asking how many solutions. I want to know how much the value of W is. Well, 3/4 of 12. If I have 3/4 of 12, remember all you're doing is distributing this right here. So when you take your calculator, you would put in 3/4 times 12. What it should give you is, if I'm not mistaken, 3/4 times 12, that's 30, so it'll be 9W. Oh, I'm so sorry about this pen. Give me just 1 second. So 3/4 of 12 is 9. 3/4 of 4, so 3 times 4 is 12, divided by 4 is 3, right? And then we have distribute on the back side here. 2 times 4W is 8W. 2 times -10 is -20. All right. So if I go ahead and solve this out now, we still got to go a little bit further. Okay. So if I have box, circle, box, circle, right? Okay. So we're going to do that. All right. So I'm going to come right over here and write this again. So 9W plus 3 is equal to 8W minus 20. All right, so now let's move some things around. So if I subtract the 8W to get the variables on one side, I have 1W plus 3 is equal to, this is gone, -20. Well, box, circle, so I need to move this 3 to the other side. This goes away, right? I'm left with 1W equals -23. Now, I know I don't have to divide this by 1 because it's a positive, but I'm going to anyway because I want you to make sure you understand. I've always told you, if you have a number in front of the variable, you're not quite finished, right? So I have W equals -23, right? Okay? Y'all give me just 1 second. I'll be right back.